conference, and it was probably 2 or 3 years ago that I first met you, and I'm so pleased that you could be here today to join us. So we'll bring you up now.
There. Yeah. Thank you, Woody. It's an honor to be here today.
Here, I'll set this over here.
Oh, did you? Oh, wait, okay, that's yours. Great.
There you go.
This goes here, this goes here, this opens. There it is. Okay. Okay. I'm really happy to be here at the Mob Programming Conference because I think of all the people in the world, y'all might be like most likely to understand the idea that I have to share at the end of this presentation today, because it's weird and it's audacious, and I think it might excite you just a tiny bit as much as it does me. On the way there, I promised to talk about mental models, and we totally will, a lot. But before that, this presentation is really about opera. I'm not a music history person, but I listened to this art appreciation or music appreciation great course, and I heard about the Florentine Camerata, and these are the people who invented opera, who, right at the borderline of the late Renaissance and into the Baroque period, they created opera, which is one of the things that defines the Baroque period. And I was struck by how interesting this group of people sounded, because it reminded me of an agile team, or a mob, or this conference, the industry right now. So see how many resemblances you can find. The Florentine Camerata came together during a time where there was drama and there was music, but they didn't combine. And the state-of-the-art music at the time sounded like this. This is Palestrina. And the musical style is called polyphony, because there's 4 melodies, so polyphony. There's 4 melodies, and they're all equally important. And this music, I think it's in Latin, but even if you know Latin, you probably can't understand what they're saying. But it conveys feeling through acoustics, right? And the pleasing sounds. And the Florentine Camerata were a group of people who asked this shocking question: what if we could understand the words? Seriously. So the quotes from this paper or quotes in this presentation, everything in this font anyway, comes from this one paper by Dr. Ruth Katz that I found. It was published in the Journal of the History of Ideas in 1984. And it's super fascinating. So the Camerata were a group of musicians, artists, poets, astrologers, philosophers, also like bankers and noblemen and clergymen, a whole bunch of people who were just interested in what was going on in the world, and they got together at the home of Giovanni Bardi, who was Count of Genoa, and he just loved to have interesting people around him. So he was always inviting the intellectuals of the city to come to his house and have conversations, and also Jacopo Corsi. So we have a mix of people of different skills. We have sponsorship. We have a common problem. They wanted to reform the music of the day. Vincenzo Galilei, father of Galileo, was in this group, and he wanted to change the corrupt and incomprehensible contemporary music. and they had a common shared strategy, not tactics, but their strategy was to revive the music drama of the ancient Greeks. They thought that the Greeks probably sung their plays, and they wanted to revive that from the ancient, this like lent legitimacy to their efforts, right? Kind of like if we read computer science papers from the 1970s to justify what we're doing. But their principal aim was to find the optimum combination of words and music in order to communicate. to impact people, to convey a message and change the audience. I think they achieved that. What was the Camerata like? Well, Caccini, who was a singer as part of the Camerata, said he learned more from their learned discussions than from 30 years of descant. Descant, I had to look it up, is talking at length, lecturing, so what you're getting right now. Fortunately, we have the rest of the day to have learned discussions. But not only talking, they also had workshops, and they played music together, and they experimented. So in the Renaissance, the scientific method was also emerging. That idea of performing experiments. Vincenzo Galilei was the first one who tied weights to strings and measured the lengths of strings and experimented to find the ratios that create a perfect fifth, that make the chords and notes that we're familiar with today. So experimentation in the scientific method was new and was totally intertwined with the emergence of arts and music. There was discord. They didn't all get along. Bardi and Corsi, the two main sponsors, were rivals, and Corsi wanted to do more playing of music, and Bardi wanted to do more talking about it, but the two complement each other. And then you've got Caccini and Perry, who are the main singers in the group at the moment, and Perry wants to focus on the words with a little bit of song, and Caccini wants to focus on the song and also understand the words. But these balance, we need that sort of tension. They did code review. So they had presentations, and I find it interesting that the defenders and censors were nominated for the occasion. It wasn't just the asshole who doesn't like you criticizing your code all the time. It was really constructive feedback. The outcomes. So in the end, the Florentine Camerata definitely made history. This is an example of one of the first operas. This is Monteverdi, and he wasn't in the group, but he wrote operas based on the work of the group. He was completely influenced by the Camerata. And if you know Italian, you can probably actually understand these words. It's different, so now we can get a story along with it. And this was shocking to people. People were like, what do musicians have to do with the readers of tragedy and comedy? Now it seems obvious, but back then, this was new stuff. Not only did the group as a whole make history with the ideas that they output, but as individuals, people learned and grew, and these are some of the publications that came out of members of the Camerata. Of course, some of the first operas, but also Vincenzo Galilei's music theory. And all these people are fewer than half of the members of that Camerata that have Wikipedia articles today. I mean, really, if you're alive in 16th century Italy, what are your chances of having a Wikipedia article today? I think this group produced some remarkable people. And this phenomenon of coming out of a group with ideas and something better is not unique to opera. We'll surrender unworldly life. And this is their world will never be the same. This is my daughter singing Hamilton, the modern music drama. So they really did change the world. And this changing of the world from a team and of the members of the team happens not only in music but also in science. So Dr. Katz remarks that the Camerata is like an invisible college, which is also the key to creativity in science. We love to give Nobel Prizes to individuals, but who worked in their lab? Who did they correspond with? Ideas don't come out of the blue to individuals. The world is ready for them, and the people around them, we talk and we create these realities together, and we become greater people. Einstein corresponded with Leibniz. John von Neumann was incredibly talented, but when he went to Los Alamos to work on the Manhattan Project, 2 or 3 mathematicians also went to that project who were in high school with von Neumann in Hungary. Again, you're in high school and hungry, what are your chances of being on the Manhattan Project? But they worked together, they formed a group that made all of them greater. So the invisible colleges include tacit understandings of approach. You know, we need to agree on process to some degree. We need to agree on what we value. Priority problems means fighting over who was first. More on that later. And the shorthand communication, we can talk very quickly and communicate fast to the people that we work closely with. So that reminds me of an agile team too. This happens in art. My favorite example is Paris in the Montmartre district in the 19th and 20th centuries, where you've got the salons and the coffee houses, right? So everyone in the art industry is getting together and working on common problems such as Impressionism. And then the Impressionists influenced Van Gogh. I went to his museum when I was in Amsterdam, and the part that I really liked was all the paintings of his friends and how they influenced each other, because he went to Paris and he really learned a ton about painting. And his brother remarks here on how he formed a circle, and we grow in these circles, in these camaradas that we become part of and form around ourselves. Gauguin in particular was very influential on Picasso, who worked very closely with Georges Braque, and also here just Picasso throughout his life had just dozens of people in and out of his living room and his circle, and they all influenced each other. And these are a bunch of writers and photographers and philosophers. And another person who was part of Picasso's circle, well, where did I lost the slide, was Alexandra Ektra, who took what she learned from him back to Kiev and to some people she went to high school with, one of which was Alexander Bogomazov, and there's his painting on my bedroom wall. It's just a print. Right, so from Impressionism to my bedroom, the influence, oh, there's Alexandra Extra, there she is. The influence flows through groups of people as we talk to each other, as we work on things together. Examples of software teams that went on to produce amazing people as well as solve problems. So ThoughtWorks in London was a hotbed of ideas in 2003 to 2006-ish, and this is where continuous integration and continuous delivery came from. Jez and Dave were not on the same team, but they were part of the same consultancy, so they were talking to each other and with all these other people. Sam was on both teams, I think, and now Jez has all these other books. Dan North invented BDD, Nat Price, and growing object-oriented software, and of course, Sam, the microservices prophet. All of these people came out of the same team. Is that a coincidence? I don't think so. These are very different ideas, but that team begat some really interesting people who went on to do even more interesting things than they did together. Another example, bonus picture of Jez in Budapest. He's going to regret letting me take this. He's imitating the bridge lion. Another example of a team like this is Spring, also in London, around the same time, I think. Apparently London is the Paris of programming. So all these people were on the Java Spring team, and they had the common problem to solve of, oh my God, do we really have to use J2EE because it's awful? And they came up with a solution together. But this team also produced a remarkable number of CEOs and founders and partners and things. And Rod is my CEO at Atomist, and Christian is our VP Engine. Oh my God, he's an amazing developer. So great, the conclusion is, great teams make great people. You want to take a bunch of great people and say they'll make a great team. It's the other way around. So great teams make great people. Why? Why is that? I think I have some theory that produces a satisfying answer. And that theory comes indirectly from Gregory Bateson. So he is one of the pioneers of systems thinking called cybernetics in his day. His father invented, or at least named, genetics. And Gregory Bateson's Camerata was the Macy Cybernetics Conferences, sponsored by the Macy Foundation. And they had like 10 conferences over 6 or 8 years or something where they got together and thought about this. And I think systems thinking is the modern day analogy to this, an analogous thing to the scientific method. Because in the Renaissance, it was the scientific method that was a new way of thinking about stuff that let us solve problems and go places we hadn't before. And it also impacted art. And we moved forward. And today, I think it's systems thinking that can help us overcome limitations of the scientific method and think about things in ways we couldn't before. So Gregory Bateson was influential in that. Another of his contributions was Nora Bateson, his daughter. Nora Bateson wrote a book called Small Arcs of Larger Circles, which I just love, and also she blogs. And she came up with this word, symathecy, because systems as a word, it's not enough. It's easy to think of systems as machines, as mechanical connections. And in the 60s and 70s, they tried to like model whole ecosystems, and they were quite certain that if they could just get enough of these interconnections and these numbers into the computer, that they could predict the outcome of the ecosystem and they could tweak it and control it. But they were wrong, because systems are more than their parts, and they're more than the interactions between the parts. Because the parts in a living system like an ecosystem are changing as the system runs. As we go, we're learning from each other. So the system as a whole is learning and responding to its environment. And the different parts of the system, in this case represented by people and our environment that we control, our desks and our chairs and our computers, we move them around. So our environment changes because we change it, and we change it because we talk to each other, and we learn from each other, and we learn from our work. And this is more than just a system. So Nora Bateson created this word, symathecy, from the Latin sim, together, and mathesy, learning. So a symathecy is a learning system made of learning parts. And the system is not the same from moment to moment. The interrelations are not the same because the parts are not the same. So these are my notes from Woody's presentation yesterday. He quoted Akoff as, a system is not the sum of the behavior of its parts, it's a product of their interactions. But I'm telling you, it's more than that, because the parts are a product of the system, of all of our past interactions. We're not the same team from day to day. The output of everything we do is our side effects on the world, yes, and the next version of ourselves, the next version of the team. We're constantly changing and growing, and so no, you can't model that with numbers and pipes, because we don't stay the same. And that explains, this symathecy explains why it takes a camerata to grow. We, as people, do not grow by ourselves, we grow with each other. So sometimes our camerata is our team, that's the best, because then we also get paid. But other times our camerata is user groups, it's our lean coffee group, it's this conference. We talk to each other, we have common values, and we form a common language, and we grow. Okay. But what Nora Bateson doesn't have that we do is experience in a software team. And there's something about a software team that is different from other symatheses. Because software is, by many orders of magnitude, the most malleable material we've ever had for engineering. And when you think of a software team, a team is defined as everyone you need in order to succeed. And when success as a software developer for me is running useful software. And in order to do that, yeah, I need my team, but I also need the software itself, and I need the servers that it runs on, and I need the software that I use to deploy that software and to test that software and to manipulate it. So the code, and more importantly, the running software in production, including its database and everything, is part of my team. And it learns too. It learns because I change it. And everything, my source control and my deployment and my automated tests, these are also part of my team, and they learn because I change them. Personally, my definition of legacy code is code that I can't change because I don't have it in my head anymore. I don't understand it, so I can't change it, so it's not a living part of the system. So us and our software, we form a socio-technical semathecy. And when we include all of this, then we can think consciously about how much effort to put into these pieces of our system to teach them how to better serve us and our users, our environment. It didn't used to be this complicated. You know, when I was a young programmer, I was assigned a piece of a program to work on, and I had specific things to implement in it. And when I wanted to put some data in, I asked, how do we use the database? These days, I ask, which database shall we use? Or databases, and how shall we get from here to there? That's the real hard problem. So the impact we can have, the semathecy that we can actively change as we're part of it and growing with it, is determined by how much of it we can understand and hold in our heads, how much we can model. So now we get into the mental models. As I've become a senior developer, my vision of the world has grown, and I try to keep in mind my whole team and all of the software that we're responsible for. And that's a lot bigger, and it's a lot more complex. And this semathecy thing, by the way, it also explains why we need to bring our whole self to work. Because if we are growing and as a living part of a system, a living part of a living system, yeah, we have to be alive in that system. So I need to be alive in a system, and then I can look beyond myself and see the whole system that I might impact, and adjacent teams, and how my software impacts their software. And in order to change this system, I need to have a mental model of it. So Brooks' law, from the Stella report, which is referenced later, says that in a system anywhere near this complex, our mental models are always out of date, they're always incomplete, and they're out of date and incomplete and wrong in ways that are different from person to person. A lot of what we do in talking to each other, the coherence penalty of adding more people to our teams, is the time we spend getting our mental models sufficiently coherent that we can communicate. So we need that mental model, and they're different from person to person, and that's okay because we can't keep the whole thing in our head, so we need like overlapping and reasonably consistent mental models in order to change the system. There's a couple reasons why this is, well, there's a lot of reasons why all this is hard. I'm going to tell you about two of them that are kind of surprising. One is, and this also comes from David Woods and Richard Cook out of the Stella report, the socio-technical system that we're part of is not uniform. These people in the semathecy cannot just look down and see the programs, right? Our programs that are running, that are alive and part of the system, are like in digital space, and we don't have Tron yet. We can't just jump in there and go visit them and interact with them. We can only do that through the line of representation, through the tools that we build or operate, or pay someone to operate, such as our source control managers and our editors, and our screens and our keyboards give us this representation to both discover what our software is doing and build and verify our mental model, and also to control it, to change it. So from our editors to, at a very crude level, SSH, we can operate and look at our software, but our logging and our monitoring is all, they're all ports on this line of representation. And that abstraction that we have to work with makes it a lot harder to build our mental model than if we could just look at it. And as these systems get more complex and PS just doesn't tell us everything that's running anymore, this gets harder. And so we have to consciously build our own tools, build our semathecy in order to keep our line of representation useful to us. I like this concept a lot because it lets me explain Atomist, which is where I work, in one sentence. Atomist is about moving coordination from above the line to below the line. Automated tests and continuous deployment was a step in this direction, and we are working on tools to help you do a lot more in this direction. So now you know what I do. All right, there's another reason that this is incredibly hard. Building these mental models is hard, and it's counterintuitive. Valentino Breitenberg, in his book Vehicles, describes the law of downhill invention, uphill analysis. What this says is, it is easier to build a complex system from scratch and build your mental model as you go than it is to come to someone else's complex system and figure out how it works. This is not obvious because you'd think it would be easier to say use React than build your own JavaScript framework, but you'd be wrong. Why are there thousands of JavaScript frameworks out there? Because it's easier than learning to use, much less change, someone else's. This is why legacy code is more interesting and harder than Greenfield. Why does everybody want to do Greenfield? It's easier. Why do we have not invented here? It's easier. People feel productive building that library themselves, but they're being lazy. Because even with all the hundreds of people who've put effort into documenting and Stack Overflowing and making React a very well-designed, carefully implemented JavaScript framework, it's still easier to write your own for just that one thing that you just desperately want to do. But nobody else is going to be able to come to yours and see it. You'll be like, oh, what do you mean? It's totally easy. Obviously, you typed this. No, it is not obvious to anybody else. And this is a really hard thing to empathize with because you, as someone who's built this system, if you're the purple developer here, you've built this and you're working on this system and it's in your head and you don't know how much you know. It's really hard to put yourself in the place of someone who didn't build the system or hasn't been working on it for years. And what's more than once in my career, I've been in the place where I'm like blue or green over here, and I'm supposed to be helping with this system, right? But maybe I'm only half time assigned to it. But even if it's my job to help with the system, but meanwhile, purple developer here is just zooming along, and it's quite easy as this purple developer to change this system so fast that these people can't catch up and will never, ever, no matter how smart they are, be able to reach your level or anywhere close of the model of the system because you can change it faster than they can pick it up because they're going uphill and you're on a sled. So as this purple developer, you get to be 10 times more productive. You get to feel really good. And you look super smart and people think it's you that's amazing, but no, it's your mental model is that secret weapon. And nobody else can just acquire that. It is not easy, it is really hard. And this is why this is my favorite thing about mob programming. It's not the only reason, but my favorite thing about mob programming is that when you work together, that's when you really share the mental model. That's when you change the system together, that's when green and blue also become part of the Samantha C because they get this code in their heads. And then it's not legacy code to them because it's alive in their heads. They can change it. It's now part of our Samantha C together, and we can consciously work on it. So that's my favorite thing. And this, but that 10x developer thing, it's a problem because we get to that conflict between individual and group interests. Now, in the Camerata and in science, there's the race to be first, to be credited with the original idea. We don't have that in our team so much as a conflict between individual productivity and my enemy, the annual performance review. In the Camerata even, years later, Caccini, who was a singer in the Camerata, he became a composer as well after that. And he fought with Perry a little bit, and also Cavalieri, who was in Rome, so he wasn't part of the Camerata, but he corresponded with them. So he was like part of their thought development too, and they argued over who invented the stile representativo, which is that shocking innovation of one melody with a little bit of accompaniment. That you can understand. So they fought over this in the Camerata a bit. And yeah, in science, you worry about who made these original contributions. In our agile teams, it's more about productivity than original contributions, and all I care about is that my team knows I contributed. But that brings us to the other side of productivity, the team side, is if we're going to take away the incentive of personal productivity, if we're going to combat that, we need an alternative. And that alternative is generativity. Instead of being about what I produce, it's about what is the difference between what the team makes with me and without me. And not just what the team makes, but also what the team becomes with me versus without me. Because again, it's not just about our output, it's also about the next version of ourselves. So I propose that we evaluate our team members on their generativity, because often that 10x developer who's not sharing his mental model, he's just getting shit done, it's quite easy to be the most productive member of the team and negative generativity. Because maybe if that person left, the rest of the team would mob on it. It wouldn't be changing out from under them. They would change it together. They would build a common mental model and pretty soon be able to do more than that developer is doing now. So I don't believe in 10x developers. I think that's a very bad sign, but I do believe in 10x teams. If you want to be a great developer, ironically, being great right now, being great yourself, is not the way to get there. You need to get there obliquely by being part of a great team. And because great teams make great people, you will yourself become great when you aim for the great team. You get both or neither, and if you aim for productivity, you get neither. So what this means is, great developers aren't born, and they can't be trained. We can't make ourselves a great developer because we learn as part of the system. Great developers are symathicized. And that means for us, we need to build our camerata. Maybe it's our team, maybe it's our meetups. We have great programming meetups in St. Louis, and I see the same people every month or more. And we talk about things, and that's a building, and we can do that consciously. We can make our own symathices if work is not so compatible with them. But there's another piece in this paper, this Camerata paper, that really, really struck me. And then like blew my mind. It was talking about the surrounding culture. Because in order to have one of these great teams, we require certain conditions to exist. So the Camerata was in the Renaissance. There was a lot going on in the Renaissance. People were thinking, people were making art. They were like midwives to a century that was pregnant with social, ideological, and cultural ideas. I think we're in another of those periods because we have the opportunity to form these teams, these agile teams with multiple peoples. The very existence is a product of our time. And back in that day, they finally were able to form heterogeneous groups and talk and connect artists with philosophers, with writers, with clergymen, with noblemen.